Okay, Algebra 1 fans, our topic for today, Notes 7-2, dividing monomials. So we've talked about multiplying the last few lessons. What happens now when we divide? So after this lesson, our objectives you should be able to divide monomials using exponent rules, simplify expressions containing negative and zero exponents. Before we begin, let me give you your joke of the day. What did the pirate say on his 80th birthday? Aye, matey. All right, so here we go. Dividing monomials using expansion. And we're actually going to start with an example of multiplying fractions. So we have multiply 1/2 times 2/3 times 3/4 all the way up to 9/10. The rule for multiplying fractions is you multiply the numerators together, you multiply the denominators together, and then you divide, you reduce. However, it's sometimes easier to divide first, where if I think of this as one big numerator, and everything here is multiplying in the top, and everything is multiplying in the bottom, what I'm going to do is divide first. Anything in the top that I can divide with the bottom, I am allowed to reduce that. So, for example, 2 divided by 2 is 1. So I'm going to cross that out because that's just 1. 3 divided by 3, 4 divided by 4 is 1. Any number divided by itself is 1. And now what you're left with is 1/10. Now I show you that because to start this off, to kind of figure out what the rule is, I'm going to use expansion. So number 1, let's say we divide with variables now. X to the 6th divided by x squared. I am going to write out x 6 times. I'm going to expand. X squared is x times x. Now, you can divide out. If you have anything divided by itself, we know that that is 1. X divided by x, we don't know the number for x, what the value is, but anything divided by itself is 1. Anything divided by itself is 1. Now what's left here, I didn't write this down, but when I divide these and I just get 1, I usually put 1s in that position. So what's left? Well, we still have x 4 times here. That's x to the 4th on top. But in the denominator, you have 1 times 1, which is just 1. Now, we're going to write that. That's the same thing as x raised to the 4th. X to the 5th divided by x to the 3rd. Let's expand this. Numerator, denominator. Let's divide out like terms. Here, I'll do it this way. X divided by x is 1. X divided by x, 1, 1. So in the bottom here, all you have is 1. In the top, we have x times x. Multiply variables. Now we'll multiply. So we keep the base at the exponents. And what we get is x squared over 1, which is just x squared. Number 3. Now this one's a little different because the bigger exponent is in the denominator. Now it doesn't change the process. Let's divide out our like factors. X divided by x, 1. 1, 1, 1. Now this time it's the numerator that has nothing left, but when I say nothing, I need to be careful because this is not 0. All of these divide to 1. 1 times 1 times 1 times 1. So this is just a big 1 in the top. What's left in the denominator is x raised to the 3rd. That's it. Okay, now is there a faster way to do this? Yes, there is. If you look at, we'll go back to number 1. Look at the exponents 6 and 2, and look at the final exponent 4. 5 and 3, 2. 7 and 4, 3. What are we doing to those numbers to get our final exponents? We are subtracting. We did x raised to the 6 minus 2. we did x raised to the 5 minus 3. Now here we did x raised. I can do 7 minus 4, but I need to understand if the bigger exponent's in the bottom of the fraction, my variable is going to be in the bottom. So the rule, number 1, for dividing monomials, a raised to the m divided by a raised to the n, we keep the base, but we subtract the exponents. When it's multiplying, we add the exponents, but when we're dividing, we subtract them. Now, one more thing about number 3. I'm going to do this again. In the rule, you do the top exponent minus the bottom. So that's x to the 4 minus 7. But when I subtract this, I get a negative exponent. I do not leave that as an answer. I don't leave it like that. That actually becomes 1 over x to the 3rd. Now that probably doesn't make sense right now, that move that I'm going to make there, but I'm going to talk about that later. If you end up with a negative exponent, we're going to move it all down to the bottom of the fraction and it becomes a positive. All right, so let's do some examples here. Number 4. When we divide variables, we subtract exponents. So it's e, I'm going to write it out, 8 minus 3, f, 7 minus 4. I do the top exponent minus the bottom. E raised to the 5th, f, to the 3rd. Now that is g raised to the negative 4. If I have a negative exponent at the end, what I'm going to do is I'm going to circle this term. I'm going to draw an arrow down. I will finish this as a fraction. G to the negative 4 goes down to the denominator and becomes g to the positive 4. Again, I know that seems very weird, seems like magic, but I'll explain why that works on the other side. If you have coefficients, we do not subtract 12 and 18. This is a division problem, so we divide these or we reduce them. Each of these, can we divide by something? Think of a common factor. We can divide each by 6. So if we do 12 divided by 6, we get 2. 18 divided by 6 is 3. So that reduces to 2 over 3. Now, for the variables, we keep the base. We subtract the exponents, 4 minus 6, and then y to the 3 minus 2, we do the top minus the bottom. Top minus the bottom. So we get 2 over 3 times x to the negative 2, y to the 1st. You cannot have a negative exponent. So I'm going to circle that term. I'm going to bring it down to the denominator. And when I bring it down, that becomes x to the positive 2. But I still have this 2 up top, and this y to the 1st is also part of the numerator, part of the top. And that's it. Number 6, 8 divided by negative 4, that's going to reduce to negative 2. I can divide that. X to the 13 minus 24, that's x to the negative 11. Can't leave it like that. I'm going to take x to the negative 11. I'm going to bring it down. So you see right here, well, wait a minute, there's no denominator. Well, now there is. I'm going to write that now as a fraction, negative 2. That stays up top. A negative coefficient does not move, only a negative exponent. That's x to the 11th on the bottom. Number 7, x to the 2 minus 2, and then y to the 3 minus 1, we get x to the 0, y to the 2nd. Well, on the back, you're going to learn that anything to the 0 is actually equal to 1, and that's y to the 2nd. So our answer is just y squared. Now think about this. Let's say I did 5 divided by 5. Now you know anything divided by itself is always 1. 18 divided by 18 is 1. Even though we don't know what x squared is, any number divided by itself is always 1. So you can use this rule. You can subtract the exponents, but if you get a 0 for an exponent, that term becomes a 1. What I'm going to do from here on out, since I see x squared divided by x squared, anything divided by itself is just 1. So number 8, 2 to the 6th divided by 2 to the 6th, I can subtract the exponents and get 2 to the 0, but if I have the same term, when I divide those, they just reduce to 1, and 1 divided by 1 is 1. X to the 3rd divided by x to the 3rd is 1. Again, you can subtract, keep the base, subtract the exponents, but anything to the 0 is 1. And again, the reason is, if I go back to this one, 2 raised to the 6th, that's 64. 2 raised to the 6th, well, that's also 64. Any number divided by itself is always equal to 1. So that is the end of part 1.